Good afternoon, everyone, and welcome to Ask Me About Anything About Astropreneurship. This is our monthly session that's provided to OASA to provide some questions as well as answers in terms of different topics every month. So this month, our theme will be the following: the perils of space debris, or finally called space junk. And with that, are there opportunities? Are there challenges? And what's in it for us for the future? So with that, let me begin with a little bit about OASA. For those who are joining us for the first time, OASA is the Orion Astronaut Space Academy. And essentially, we are an accelerator and helping startups in terms of organizations as well as students based here in Hong Kong. And we like to focus on development of young leaders. And as you can see here, giving them wicked problems and helping them in terms of a journey of learning, experience, and ultimately gains for their future in the new space economy. So with that, every month we have our Ask Us About Anything About Astropreneurship sessions. And this month, as we said, it's about space debris. So with that, let me begin with entrepreneurship and the new space economy. The future today, as we all know, is really looking at what lies ahead. And clearly, the key message is about the new space economy. And that's one of our driving values and credos here at OASA. So with that, Cynthia, can you pass us our next slide, please? To begin with, what we'd like to do is now take a poll. Let's just get a general understanding, everyone. Cynthia's going to put a poll up. So Cynthia, could you put the poll up? And the question to everyone is, right now, what is your level of understanding in terms of space junk, our topic for today, right? And let's say that one, that we're very, from a scale of 1 to 10, 1 would be very limited knowledge, and number 10 would be an expert. So please feel free to vote on how you feel today. And what we will do is we will share with everyone our poll findings, all right? All right. Now, I'm going to close out the polls, and then I'm going to have Cynthia join in terms of what the results are. So with that, let's look at the results. So it looks like a pretty even distribution, anyway from 1 to 8, but 5 in terms of our view and knowledge and comfort level is where 21% is where most of us are today. So that's just a good benchmark that we would like to start with. And at the end of the session, we'd like to take the poll again and see how we're doing. So moving on now, to have a bit of fun, we're going to have what we call the AMAAA Challenge. And what is that? That's really just a few questions to test your knowledge in terms of space junk. And so we have 3 simple trivial questions for you that we'd like to ask for you right at the beginning. Number 1, will all space junk eventually fall to Earth? Question number 2, what is the largest piece of space junk that you could think of? And thirdly, how much junk is in space right now? So can you please open up the poll, Cynthia? And everyone just vote. There are 3 questions here. So if you could vote for all 3 questions, and what you'll have to do is scroll down. Scroll down. So please indicate question number 1. Will all space junk fall to Earth? Do you think it's all going to fall to Earth? Yes or no? Please click on yes or no is your vote. And question number 2, what is the largest piece of space junk? So we have anything from A, 2.9 tons, B, 1.9 tons, C, 3.9 tons, and 4.9 tons. Now, scroll down your poll and you get to question number 3. How much junk is in space right now? A, 1 million pieces. B, more than 170 million pieces. C, 8 million pieces. And D, 100 million pieces. Most people feel no, that space junk will not fall on Earth. And number two, what is the correct answer? What does everyone think? Everyone thinks it's 4.9, D. Other thoughts here? The reality is that according to our research, it is currently 2.9 tons, and that's A. So 2.9 tons is the largest space junk currently available. And the third one, how much junk is in space right now? So answers to that, basically the research says it's about B, more than 170 million tons for space junk. So that was just a little wet appetizer to open up your thoughts. So with that, what I'd like to do now is, Cynthia, the next slide. It's my honor and pleasure today to welcome our guest speaker. And Dr. Sajadi, affectionately known as Dr. Abdi, we're honored to have join us here today. And as you can see here, Dr. Abdi is associated with the Genius Development as well as LSR, the Laboratory of Space Research at POC Fulham. So what I'm going to do now is turn over the stage to Dr. Abdi to let him first introduce himself and then lead us through his thoughts and sharing over the next few moments in terms of the perils of space debris. So with that, Dr. Abdi, the stage is yours.
Thank you very much, Perry, and good evening to everyone. Thanks for having me, OSA, Dr. Greg and Perry. I am Abdi, an astrochemist scientist and a STEM educator in Genius Development and Science Tech Future. And I would like to just share with you today some of my view about the space debris or space junks. May I have the other slide, please? Yes. Okay, simple definition. You can find three definitions in Webster Dictionary, or even which is also used in any scientific text as well. So debris are the remains of something broken down or destroyed. Or in geology, it is an accumulation of fragments of rock or something discarded. So with that definition, I share with you my view, the view of an astrochemist about the space debris. May I have next slide? And that is my view. Question number one, what debris are in the universe? So when I'm looking at the universe, which is the background of this, through the lens of the JWST, which is the James Webb Telescope. And then what do we see? I think we saw many debris. Many of those stuff may fit to the definition of debris. Who is among the audience agree with me that what we are looking right now, these are also the debris, the galaxies, or maybe more. Something has destroyed and the fragments are spread around.
So Dr. Abdi, that's a very good point you raised there about space debris, yes?
I think that's my view. That's something that I can call it the research point of view. When we look at the word debris. Now, another question, the range of these debris. Again, background of this slide. If you look at the red giant, I mean, this is the cycles of the life, basically, in the universe. Something is created, something is destroyed. And when something is destroyed, it makes debris. Okay, you can look at the red giant. And then red giant will eventually give us a beautiful debris. I think Of course, we have the Professor Parker, one of the top experts in planetary nebulas. Maybe he agreed with me that the most beautiful debris of the universe could be the planetary nebula. Also, you can, I would like to ask the audience, can you pinpoint more debris in the universe in this slide?
All right, I'm looking on the chat here, and I see a few thoughts. Our team has said broken rockets. Yes? And then Justin has got dead satellites. And Emma, devices left for monitoring the universe.
I think they are talking about the artificial space debris instead of what we just heard about the natural space debris.
Yeah. Excellent. Yes. Now, what I was trying to say is that exactly what you pointed out. So when we call it space debris, we have two basically grand view. One is technological one is basically the natural one. Which one we are going to see, or which one we are going to do something about it. Now, next slide, please. And this is one of the things which I called it molecular size debris. These are the things which are very, very small, the size of the molecule, and it's discarded away. And these are categorized as one of the audience very nicely pointed out. These are called natural debris. These are the most important debris actually. We as the astrochemists or astrophysicists, we are looking for the debris. We are hungry for hunting down these kind of debris. Okay, next slide, please. Yes, and that is, okay, that is what I call it, the space program debris. And of course, you are familiar with the space telescope like the Hubble. And NASA also has the office to study the space basically debris. They have the softwares to assess the danger of these space debris before they send the man-made stuff to the space. And this is, I just left the link here. This is a very, I think technological debris are a small category of what is basically is talking usually, is discussing. But of course, if you look at the grand picture of the debris, you may see that might be the comets also, which are the debris. We have to take care of them, natural debris. So my view is that let's take both natural and man-made debris into the discussion. Okay, next one.
All right, thank you.
And this is the size of the Hubble telescope. For those audience which are not familiar with the size of the space telescope, as an example of the man-made tools, which is up there, it's a 13.2 meter size of, I think, larger than the bus, and diameter of 3 meters. So that is hanging around there. And well, how do we manipulate them? I just will share you my viewpoint in a few minutes.
Great, thank you for that. And if anyone has any questions in the audience, please feel free to chat or even open up your mics and ask Dr. Abdi now. Okay, there's a hand up. Alexander has raised his hand. Alexander, could you turn on your mic and ask your question, please?
Yeah, so hi, Dr. Abdi. Thank you for your time for presenting this information. So I have a question related to man-made artificial space debris.
Yes.
And so I was thinking about, in climate science, how there are rough estimates that show like a further increase of global temperatures by 1.5 degrees will cause a climate tipping point, where like a lot of irreversible damage will be caused. And so I was wondering, is there a similar tipping point with man-made artificial space debris? A point in which there's so much mass of artificial space debris within our low Earth orbit that we also will experience irreversible damage due to this type of space debris. So yeah, my question is also just, is there also a similar tipping point that we experience with regards to space debris?
Okay, you know that I'm not expert in the climate, nor expert in space technology. So astrochemistry or astrochemists are doing the research in different way. Now, I have no idea how much the man-made space debris can affect the climate on Earth. What I can just model, because what I can model is that it depends on what material you should send over there and how much is the material. These materials are so much accumulated that it can, for example, block the sunlight, as is a very simple model. And that's what I can say up to now. I don't have any idea, actually.
All right. Well, thank you. And Dr. Abdi, we've got a question here from Justin. He's
Yes.
in a public area right now, but he's chat in a question which I'll read to you. And he said, would the debris be dangerous to other space activities, right? If so, any solutions? So that's a great question for you.
Yes. That was the most dangerous debris that was taken into account was the dust, that we call them star dust. And there is a book about that. NASA was considered this threat before sending all these shuttles or their spacecraft to the space. So there was I think about, if I recall correctly, about 5-6 years was the arguments among the astrophysicists that this is maybe pose a threat because there are the dust at the upper level of the Earth. And these dust are the size, it's a debris basically. These are the space debris, natural space debris around the Earth, which is coming from discarded away from other sources, and then it wraps somehow around the Earth. But the final assessment was that those dusts and the particles are not that much harmful to the tools. And what I have followed just recently on the damage, a slight heat to the James Webb, one of the James Webb mirrors. So for now, it seems that the dusts are not very much posing a serious threat to the basically to the space program. Still, the space program is on. But of course, if it is the debris, the comet is coming, of course, it would be another issue.
Very good. And I noticed in the chat line too, Dr. G's added a comment about the Kessler syndrome. Yes? The Kessler syndrome.
Yes.
All right, Dr. Abdi. So shall we continue on?
Yes.
Yes.
Next slide. Okay, that's my third question. That, all right, you would like to join me and study the debris in the universe or the space program debris? Which one the audience, which one you enjoy more?
All right, those who are there, the question is, which would you like to do? Universal debris or space program debris? So the universe debris. And we have a number of people here. If we look on the chat now. Both.
Nice. Okay, I just saw my very young research assistant, Mr. Firmanovich, joined this forum, and he answered number 1. Very good. Very good.
Yeah, and it looks like several more have also answered number 1 there with Matthew and Emma and our team. And also a number like Alexander and Justin and Stephen and Paul say either both, or Stephen and Justin say number 2. So Justin's got a good point. Interesting. What about alien debris?
We shouldn't right now laugh at this question, because it is the real thing right now. It is the real things, and we should think about it. And by the way, who said that we are not an alien? We are also the alien to the other civilization, which we don't know where are they. So it is a very good question, of course.
Yeah, exactly. And that's exactly the same point that Marky put as well, right? Who is the alien? Excellent. So are there any other questions for Dr. Abdi? Because I know there's some others that we have. So if we could, Dr. Abdi, let's open it up for general questions from the participants, yes? And we actually have a question poser today. So Cynthia, could you help us with that in terms of bringing on? Yes. Stephen Chung, it's my pleasure and honor to welcome Stephen today. And he is our today's question poser. So a little bit of background about Stephen. Obviously, he's focused a lot in terms of his career, starting off as a satellite AIT analyst. And he's currently with the Hong Kong Aeronautics Technology Group as such. So Stephen, are you there?
Yeah, right here.
Great, Stephen. Okay, we'll bring you up onto the stage. If we could spotlight Stephen and then turn over the question to Stephen. All right.
Yeah.
It looks like you're on the move. Okay, Stephen.
Okay. So can you see my face now? Yeah.
Now we see your feet.
How about
there
now?
you are. Perfect. Perfect.
Okay. So I'm now right now working at Hong Kong Aerospace Technology Group, which I help prepare the the incoming equipment installation in the Advanced Manufacturing Center in Chung Kung O, as well as some other things related to Advanced Manufacturing Center. So my master degree was in Hong Kong U, which I studied Master of Science in the field of space science. My undergraduate degree was in CUHK, and at that time I was studying in electronic engineering. So for my work, currently we are going to receive those equipments from the mainland China, and then we are gonna have to learn and prepare for the manufacturing satellites in Hong Kong. Yeah.
Right. Okay, and your question, please. We've got it here on the screen. So.
Okay. So the first question I would like to ask you. Yeah. So first one, in which way can we mitigate the threats of space debris and utilize the current space debris? So this question just asks you, it's open question about how you think of the space debris, especially the artificial ones that come from the space program, maybe during the space program or after the space program, those decommissioned satellites. And before the space program, for example, those fragments from the rockets. So it's just an open question. Yeah.
With that, and Stephen, I'm going to ask you if you could just mute yours for right now. You've got a lot of background noise, if you could, just for a moment. And let's let Dr. Abdi, but this is questions open to Dr. Abdi and everyone. All right, let's start with Dr. Abdi, your thoughts here.
Now, I give you the funny answer. For the man-made debris, which are left over there, I would catapult them all to the moon. There is no other way, in my opinion. Now, how do I catapult them to the moon? Well, that's the things that I don't know, but that's the idea. For other debris, which are the natural debris, we have the problem with them. And you see that what can be done is that the astronomers are 24/7. I'm not the astronomer, I'm the astrochemist.
Right.
24/7, they monitor the motion of these celestial objects and these stuff to see that at least to have some estimation of when these guys are hitting us or is evading from us. Now, in terms of what these, some of these natural debris are made of, some of them are very puffy. Some of them are very puffy. So if they are so big, it doesn't mean that they are so massive. Some of them are so puffy with a less dense. So if they come to us, I think that the friction with the Earth's atmosphere can evade the threat. But if the bigger ones, I mean the one which is denser, not necessarily the size. If the material is, again, for the material, I have to say something. We don't know nothing about the material in the space. I mean, we see something, but the material inside the space are totally different from what we have in our lab. And the properties of them are so much different. So in some cases, we see some overlap, but in many cases, we don't see. So those materials, whatever they are, maybe from the aliens, that's the correct terminology. Maybe some unknown materials has been formed because they are inside the space, which is a kind of mysterious laboratory. A lot of radiation is there, a lot of fields are there, crazy magnetic fields, crazy gravitational field. You don't know how these things are changed the material and what could they produce then. And then these guys are coming to us. Well, it would be very dangerous then, if those kind of very dense material. So, for example, I just add one point. The most dense material that we know on Earth is the osmium. It's a denser element in the periodic table. But does that mean that there is no other denser stuff in the whole universe? So this is the things that it's open question. I don't know the answers for treating the natural debris. Either just want to study them. We have just to study, to keep studying them.
All right. And Maki also agrees with your point here. Now, Justin, let me read out his question because I know he's in a public space, so he cannot turn on his mic. But is the problem worth fixing? In other words, should we really focus some time and effort to try to come to some remedy here? So, or if we redirect it to the moon, would there be a cheaper way to direct it somewhere else, perhaps an empty space? Just a curious question, yes?
Yes. I don't reject any opinion.
Yeah.
We can throw it away and just evade it. It's a simple idea. Just let's get rid of it.
Yes. And obviously good food for thought for us to think about further, yes? So
of course.
Yes.
Yeah, I'm just adding few points to this question. So regarding to the urgency, I would like to say that, there are some satellite constellations. For example, SpaceX has its own Starlink constellation, which will be commissioned completely in the coming year, and it will consist of 42,000 satellites altogether. So that's a huge number to us, but not to the space. But however, we still have some other companies join this competition of satellite constellations. So there will be the problem if those companies commission their satellites to the space, which will be quite crowded in the coming few years. So that's what I would like to say about the urgency.
All right. Thank you for that, Stephen. And I'd like to share a couple more comments here. Alexander said, Dr. Abdi, that should governments intervene to prevent this proliferation of artificial space debris? If so, how can governments intervene, and what impact would it have on space-related markets? So a thought, how engaged and involved should the governments be involved in this?
Well, I don't know that that aspect of the work. What I say as a scientist is that I don't see any limitations for sending the stuff out there. Okay, because we have to explore. There is no way. It's like that. We have, if it was like to stop anything, we should stay in our cave forever. Or even right now, is the virus is out there. Nobody cares right now. And then they go head to head to the virus, and I love that. So that is us. So we cannot limit our curiosity. We are curious, we send the stuff out there. Whatever it happens is like the trash bins in our homes or in our countries. We will find some way, the scientists will find something to get rid of this. And as much as we have the scientists and the people join the scientific communities and think in a scientific way, I think it would be safe. That is the humankind activity. It doesn't relate it to the governments.
Right.
That's what I think.
And it's interesting because that was also mentioned in the chat that, you know, like climate change. Yes. At
But
one time. Yes,
well,
please.
There are, if any kind of human activities have a lot of positive outcome and negative outcomes. But none of them, if we see the history of the development of science, none of them was posing the human curiosity. Atomic bomb is there, knife is there, spears is there, a spoon is there. All of these beautiful and of course the dangerous things are there. I think we shouldn't fight with the history, and we should let it go with more curiosity. I love to see what is out there, personally.
Great, great. Now, what I'd like to do is invite some of the contributors here who've been in the chat line, maybe to just share their thoughts as well.
Very nice.
I see Paul Coe there. He's mentioned a lot of resources and also some thoughts in terms of the major challenges for Leo debris.
Yeah,
Paul, can you join us?
yeah, I just put up a link to. There's many maps and or websites that show like the tracked debris and the gravity of the the magnitude of how much debris is out there. But one of the biggest thing I see with space debris in Leo orbit is the actual hazards it poses to manned missions in the future. And not only that, but like the hazard it poses to other spacecraft, like commercial spacecraft, like satellites, knock out like a weather satellite or something like that, and we lose a lot of the services. So yeah, there is this problem. It's not I think it should be viewed differently than like a pollution issue, but it actually poses hazards.
Great, Paul, for that. And I see also here our fellow OASA Executive Vice Chair, Quentin Parker. Quentin, can I call you to join us and share a comment or two?
Hi, Perry. I'm disturbed to see that thing around your neck. What's happened?
Oh, that's another session. Okay.
Okay,
Yeah.
another session. Right. Let's get back to this one. Look, what has just been said by Paul. I mean, it is pollution, though, in a way. I mean, we're polluting the low Earth orbit with vast amounts of debris from thousands of satellites, some of which have already collided into each other, some of which have been deliberately smashed into one another. Both America, Russia, and China have done this, creating hundreds of thousands of small pieces of debris and larger pieces. Just a few months ago, a small piece of debris shot through the robot arm of the International Space Station, and that made quite a bit of news. Had that piece of debris been a few meters lower, it would have gone through the living quarters of the International Space Station, and who knows what would have happened to the inhabitants then. So it is, I believe, an increasingly existential problem for the survivability of low Earth orbit. And so something does need to be done, and for that you need international collaboration across, global. It needs to be agreement between all the major spacefaring nations of how together they can cooperate to address this problem. It's not a problem that one country can just try to take on for the rest of the world's benefit. It needs to have coordinated and cooperative effort by all the major spacefaring nations, who, after all, are the ones that are doing the problem in the first place. So there are technologies that are being developed and examined to try to help to deorbit lots of the thousands of defunct satellites that are currently having this space debris. But once you get rid of the big parts, that's fine. But what do you do with all the tiny parts? All the small parts, with a centimeter or so, that traveling at vast speeds relative can punch massive holes because of the kinetic energy through any spacecraft. So look, it's a serious issue, and it's not going to get any easier, because things like the Starlink mission are putting thousands of microsatellites up into low Earth orbit. And so it is a problem. There's no easy solutions, but it will need coordinated global collaboration and cooperation to address it, in my opinion. I'll stop now.
Okay, thanks very much for that, Quentin. And I notice here that Martin has his hand up, so maybe I'll call on Martin. Martin, can you come to the stage and share with us your thoughts or questions you might have? And then we'll go on. Hi, Martin.
Hi, everyone. Dr. Abby, I have a question. For the artificial debris, I've not, as I personally know, I know that there's few ways to take away the debris from the space, and including shooting a net to grab the space debris, or using a robot arm to grab it and take it to the Earth. And in this time, what is the most effective or feasible ways to take away the debris? What do you think?
I think the net one is much more feasible rather than the arm one, because these stuff are some parts maybe are so small. So in my imagination, because I'm not the expert in the technology, space is something very serious stuff there. Engineering and these stuff are involved. So, but in my scientific mind, yes, grab the net and then catapult them somewhere else. That's the only things that we can say. If you ask the other one, I don't know. I haven't heard anybody has any clear. Then the net one, I am with the net one. Yes, net one and then catapult it. Yes.
Yeah, but in theoretical it's possible. But in reality, how would you differentiate those space debris from those workable spacecraft? For example, those decommissioned satellites, how would you classify them as space debris instead of just randomly chosen and so on and so forth?
No idea.
Okay.
My short answer, no idea.
Yeah, that would be so hard.
All right. Thanks for that, Martin. I see we have a lot of good questions here. And since we have this opportunity to have Dr. Abdi with us together, I'd like to share a thought of how we can move forward. Technically, we're supposed to finish at 7:15, but I don't think there's a lot of excellent comments and questions. So Dr. Abdi, with your permission, could we carry on further past 7:15?
Please, I would be happy to share my thoughts.
Excellent.
So I'm here if anybody has a question, or even I learn from you, of course.
Excellent. Thank you for that. And just to let everyone know, I have to sign off right now, but I'm going to pass the baton to Dr. G, who will help moderate the remainder of today's session and also close up and announce what our plans are for next month. But Dr. Abdi, thank you on my behalf, and also Asa.
My pleasure.
I encourage everyone to continue on. And with that, I'm going to ask Alexander. Alexander, could you please share your thoughts, because you've got a great consideration here in terms of playing devil's advocate.
Yeah, thank you so much, Dr. Abdi, again for all of your comments, and your perspective on not limiting curiosity. I think that's been the crux of the debate with innovation throughout all of history, right? Like ever since we have our coal inventions, we've been thinking we shouldn't limit our innovation. And now that we're looking at the space frontier, we're again asking this question: should we limit our curiosity? Do we need regulations, and what impact will that have? And so, you brought up some really good points in terms of saying that we shouldn't limit our curiosity. But I was just thinking, right, if the long-term trade-off of continuously fueling our short-term curiosity is a situation similar to something like the Kessler syndrome, where low Earth orbit essentially becomes so crowded that we can't safely launch any more astronomical instruments, then would you say it's still worth it that we continue at our current rate of launching astronomical instruments into low Earth orbit? Or do you think we should reconsider the amount of things that we're launching into space, and perhaps also focus more on increasing awareness and potential talks about regulation for space debris? Thank you.
Thank you, Alexander. Now, as I reiterated, I myself said no limitation, no regulation. Okay, we have to try. Okay, we tried it, and then the lower orbit is completely saturated. So what should we do? We are the scientists. We have to go and solve the problem. That's my answer to any problem. Virus. Should we stay at home? No. We should go and find the answer. We shouldn't be scared. That's the humanity. If we are scared, we lose. We should head on to the problem. Any time that the human being was head on into the problem was evaporated. And that is, I just recall from a book which Max Planck has written about the destiny of the science. There is no destiny for the science, but the enjoyment or the efforts that the human is put to find and solve the problem, that is the engine for the science. It goes into infinity. So this is, I think, the lower orbit saturation, the technological saturation of the debris. I think the scientists can find a solution. I saw that Professor Parker put a method, laser shooting this stuff as one of the techniques. See, it might disintegrate the parts into a smaller one, and then the rest we let the nature to do it. Okay, so if they are so big and we turn them into very, very small, probably the way is open, right?
Thank you, Abby. That was a good question, Alex. Testing, can you hear me? I'm good? Okay. No, Perry has to run off, so I have to say thank you to Perry. He's getting in line to a hospital, so hopefully he recovers soon. Now, any more questions? Let's raise a question on the side. Okay, let me know, and then we'll get Abby to bounce some ideas off you. Any more questions? Okay. I've not. I know because we're supposed to finish at 7:15, so we're overrun a bit. So Cynthia, can I have the next slide, please? Okay. All right. Now the next month we're gonna focus on space tourism. Okay, and again, the idea is very much on entrepreneurship. You know, how can you actually create a solution? And that's what entrepreneurs are, right? Like exactly what Abby said. Is much more than just looking at a problem, but finding a solution to a problem and potentially finding a market to it. So we're not saying that you're going for, a big business. This is actually invented something you can sustain. So space tourism is the next one. We're looking to get professors from Chinese U or even Poly U to speak on this. Okay, and for the space breakfast, by the way, we're also going to be talking about space tourism, and we'll be touching on the three titans we're competing, including suborbital travel. Okay, so this is going up and down, anywhere, point A to point B, anywhere in the world in less than an hour. That's going to be very disruptive. Okay, all right. Any other questions before I close? And say thank you to Abby for coming in. Thank you, Abby. You've been a lot of fun. Any questions?
Thank you, Quinto.
Okay, Quinton, you okay, Quinton? All right, Quinton should be back. Alex, last question. You raise your hand. Go ahead, Alex. Alex, did you raise your hand, Alex? No?
Oh, no, sorry. Yeah, that was a mistake.
Okay. So anything from Martin, anything from Steven? Last word, guys?
Yeah, I'm okay. Yeah.
Okay, thank you, Steven. Thank you for doing this, even though you're on your way home. Steven's lucky. He's got into a very good firm, Hong Kong ATG. So it's going to be one of the new satellites production companies in Hong Kong. Okay, anybody else before we sign off? We're all good?
Yep, all good.
Okay, thank you. Cynthia, any last slide? This is the last one. Oh, okay.
The last one. Oh, join us.
Very important.
This is the last one.
With us.
This is the last one. Okay, so become Oyster friends if you haven't done it. So just click on that and then you're on your way. Okay, so we'll see some of you next time. Join C at breakfast if you really want to have good discussion on the business side of space tourism. But if you want to hear about the entrepreneurship and some fun, the format is very different, as you can see. Okay, so thank you, Stephen, again. Thank you for the poser, Martin, and also Alex. Alex, great questions. Okay, guys, we'll see you next time. Thank you, Abby.
Yeah.
Bye, everyone.
Thank you so much.
Bye, Quinton. Bye,
Bye.
Alex. Bye,
Bye,
everybody.
Abby.
Thank you so much.
Bye, Dr.
Bye-bye.
Bye.